Hello, welcome to this video where we'll be talking through running the standard multiple linear regression. First of all, we've got three hypotheses that we want to test using the regression. And based on that, hopefully you've identified which you think are the IVs, or predictors in regression speak, and which is the outcome variable, I've listed it as DV there, but outcome variable. And then we're going to take you through running the regression, and it will involve these variables from the dataset. So if we go to the dataset, a lot of the assumptions that we need to check within regression can be checked as you're doing the regression itself, but there's still some ideas that we should be looking to see if there are any extreme scores on any of the variables, the continuous variables. Not because that's an assumption of the regression per se, but just to double check there's nothing extreme going on. But for now, we'll just jump straight into doing the regression. So we go to Analyze, Regression, Linear. And we know that gender is one of the variables we're interested in. And we're going to enter all of our predictors into a single block all at once. So we'll leave the method as enter, which is the default method in SPSS, which is the standard method. We also want to include a measure of the importance. So importance, materialistic aspirations, and attainment of materialistic aspirations. Those are other predictors. And our outcome variable that we were interested in was cognitive well-being. So we'll transfer that over there. Okay, so if we go into the statistics option, we want the descriptive statistics, we want the part and partial correlations, we want some collinearity diagnostics. That's an additional, we can ask for that. Confidence intervals, again an additional, but APA style is moving more and more to including these, so we'll add them in. The Durbin-Watson, and what the hell, we go for a case diagnostics as well, and we'll click continue. And the plots, now the bog standard, the traditional way is to use the standardized predicted values along an x-axis of a scatter plot and plotted against the standardized residuals in the model on the y-axis. But we'll also ask for the partial plots to be produced, and we'll also ask for a histogram, a normality probability plot. This will help us to really check the issue of normality in the data. So we'll click continue. We're going to save, and we'll ask for Mahal distance and Cook's distance. These will help us to identify if we have any multivariate outliers which are particularly problematic in regression. And we'll also ask for some studentized residuals. And we'll click continue. And then options. We don't have to worry about this because we haven't got any missing data, so we can just leave it as the default as listwise. Click continue, and then we'll just run the regression. Okay, so first of all, we can see that we've got 178 cases. We can see the means on the variables, and we can see all of the variables that have been entered as predictors, and that we can see that the cognitive well-being mean score has been entered as our dependent variable. Okay, so I'm not going to go into, I'm not going to interpret this in too much depth, but we'll look at the some of the assumption checking. So the first thing we'll look at is our Durbin-Watson. We can see that that is 1.4. Usually we're aiming for 2, but Andy Field argues that if it's within 1 to 3, then it's not too concerning, but that is a little bit further away from 2 than we'd probably like it. So that suggests that there is something going on with the independence of error, that possibly we haven't included a variable that we should have done, or actually what it probably suggests as a good thing to do would be to mean center our two continuous variables here, which we haven't done. But I'll talk through that later on the day. So the ANOVA, we've got, we won't do that now, we'll leave that to the interpretation bit. Now, the next thing we want to look at in terms of the assumption checking is this. So we've got the tolerance and the VIF values, variance inflation figure, which is if that value is greater than 10, or if the tolerance value is less than 0.1, we have a problem with multicollinearity. And if we identified that, what we could do is look back at our correlations and see, well, which predictors are really strongly correlated with each other. We can see that in this case, the strongest correlation is between materialistic aspiration, importance, and attainment scores. So we have a strong correlation there, but it's not too strong, and obviously the VIF and the tolerance values indicate that there isn't a problem with multicollinearity, so we can include both of those things in the model. So the next thing we'll look at are the Mahal distances. What you'd need to do there is to compare that to a table of values. And if our value in the maximum column here for the Mahal distance is larger than the table of critical values, as they're called, then it suggests we have at least one multivariate outlier in the data. But for a model that contains, so we've got 1, 2, 3 predictors, the maximum Mahal distance, the critical value would be 16.27. So looks like we do have some multivariate outliers in our data. But actually, if we look at the Cook's distance, as long as that value isn't greater than 1, then the multivariate outliers we have don't seem to be having too much of an impact. So if that value, the maximum Cook's distance in our data set, is greater than 1, then we have at least one case where the multivariate outlier is causing an undue influence on the model overall, and we should go through and look at perhaps removing it or so on. In this case, it suggests that because that value is less than 1 there, that we don't have anything too concerning to worry about. If we look at the largest studentized residual and the smallest, again, that's within kind of 3, so 3 standard deviations. So that's nothing too concerning either. So if we look at the next chart we have is the histogram of the standardized residual values, and we see it's not perfectly normal, but it's roughly normal. And again, if this was perfectly normal, every data point here would fit on the line perfectly, but we can see there's a little bit of a deviation. So it's not perfectly normal, but it's not far off. The next thing we're interested in is this, the regression standardized predicted value against the regression standardized residual value, the scatter plot. And if these values are spread out, sorry, these data points are spread out in a roughly kind of rectangular shape across the whole thing, there's no clear kind of funneling or really obvious curving going on, then it suggests that it should be okay. We do have something going on a little bit here that suggests it might not be, we may have a problem with potentially either linearity or potentially homoscedasticity, or heteroscedasticity, which is where the regression model is better at predicting some values on your outcome variable than others. And actually what we want is it to be equally good or equally bad at predicting all levels of our outcome variable. So it's not too concerning, but that, again, that's something that could be improved by mean centering our variables. Then we've got our partial regression plots, and what we'd be looking for really is a nice kind of clear trend, either positive or negative from that, but to show us a kind of really clear linear relationship between the predictor and the outcome. We don't really have that here, so I won't go any further now. It's I would have a look at the actual regression output itself and get a sense of what you think is going on, and we will come back to interpretation of the data at the end of the sessions today.